Today, we're going to explore 3 different approaches to solve the TwoSum problem using Python. We'll go through the code for each solution and provide a detailed explanation of how they work. The TwoSum problem is a common programming problem where we need to find two numbers in a list that add up to a specific target value. We'll cover 3 different solutions, starting with the brute force approach. Now, before we get into the video, if you guys want to see more videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm, and with that out of the way, let's hop right into it. In this brute force solution, we iterate over the list twice, comparing each pair of elements to the target value. Let's break it down. First, a class is defined called solution with a method TwoSum that takes in a list of integers, nums, and a target value. Inside the method, we store the length of the list in the variable n. We start a nested loop where the outer loop iterates from the first element to the second to last element using the variable I as the index. The inner loop starts from I plus 1 and goes into the last element of the list using the variable j as the index. This ensures that we compare each pair of elements only once without repetition. In each iteration, we check if the sum of nums I and nums j is equal to the target value, and if it is, we found our solution. We create and return a new list containing the indices I and j. If no solution is found after exhausting all possible combinations, we return an empty list to indicate that no valid pair exists. This brute force solution works, but it has a time complexity of O times n squared, which means that the execution time grows quadratically with the size of the input list. Let's move on to a more optimized approach. Our second solution involves using a dictionary or a hash map to improve the time complexity. Let's take a look at the code. In this solution, we utilize a dictionary, also known as a hash map, to store the numbers as keys and their indices as values. Let's understand the code in detail. We define a class, or a class is already defined, called solution with a method TwoSum that takes in a list of integers, nums, and also a target value. We create an empty dictionary called nummap to store the numbers in their indices. We calculate the length of their input list and store it in the variable n. The first loop iterates over the element's nums. For each element, we use the assignment operation to associate the current number with its index in the nummap dictionary. This step effectively builds the dictionary, allowing us to retrieve the index of a number in constant time. Next, we start another loop to find the complement of each number. The complement is calculated as target minus nums I, where I represents the current index. Inside this loop, we check if the complement exists in the nummap dictionary using the in operator. Additionally, we ensure that the complement's index is not the same as the current index to avoid using the same element twice. If both conditions are satisfied, we found our solution. We return a new list containing the current index I and the complement's index nummap complement. Finally, if no solution is found, we return an empty list to indicate the absence of a valid pair. This optimized solution has a time complexity of O times n, since both the dictionary construction and the lookup operations have a constant time complexity. Now let's move on to our final solution, which is a slight improvement over this one. Our third solution still utilizes a dictionary, but with a small modification. Let's take a look at the code. The solution combines the steps of building the dictionary and finding the complement into a single loop. Let's examine the code more closely. We define a class solution with a method TwoSum that takes in a list of integers, nums, and a target value. We create an empty dictionary called nummap to store the numbers and their indices. We calculate the length of the input list and store it in the variable n. The loop iterates over each element of nums. For each element, we calculate its complement using the target minus nums I and store it in the variable complement. Inside the loop, we check if the complement exists in the nummap dictionary using the in operator. If it does, we found our solution. We return a new list containing the complement's index, nummap complement, and the current index, which is I. If the complement is not found, we add the current number and its index to the nummap dictionary for future lookups. Finally, if there is no solution after processing all the elements, we return an empty list to indicate the absence of a valid pair. This solution maintains the time complexity of O times n while slightly reducing the code complexity. It combines the steps of constructing the dictionary and finding the complement into a single loop. Alright, so that's going to be it for this video. If you guys enjoyed or found it helpful, drop a like down below. Drop a comment with any questions, subscribe for more, and we'll catch you in the next one.